So today, the Data Science Incubator is one of the last few chapters before the end of this series. Today, I wanted to talk about our packages as an infrastructure that can help you develop Shiny apps. It is one good way to scale up. So basically, when your apps become too many or become too big, then the infrastructure that an R package provides becomes like really helpful. So I wanted to kind of walk you through the process of moving from a single file app to one that is hosted inside an R package. But before we do that, maybe let's briefly discuss some of the benefits that an R package can give you as a developer of a Shiny app. And there is a bunch of things, but I'm gonna discuss only three things. So one is your workflow. So today you're gonna see me change an app from, as I said, a single file to an R package, and you're gonna see me use keyboard shortcuts and all the tooling that comes with R packages that is gonna be available to you. So if you are already familiar with R packages because you build them for other purposes, now you can reuse that knowledge in the context of developing a Shiny app. Then another great benefit is that in R packages are the main vehicle for distributing software, right? So immediately as you package your app, you have a way to share your work with the world. You can even publish it on CRAN, or you can host it on GitHub, and people can use a function like, install_GitHub and install your app right away in their systems. And then with some of the functions that you give in the package, they can trigger the app and start using it. And finally, there's more benefits, but the one that I wanted to mention third today is the idea of testing. I'm not going to be showing that today because we kind of cover testing in other series, and also because it's a kind of complex topic that might take too long. But basically, as you know, once you have an R package, it's very easy to test or to test that and the infrastructure that the package provides to test the code that you have. And Shiny is no different, so you can test any function that you write in your app. You can test it as you could do with any other normal function, except that when your functions are produce reactives, there is a different framework that you need to use on top of test.dat to be able to test those reactives. So if you're interested in building very robust Shiny applications and you're interested in testing not just vanilla functions but also reactive functions, then you need to probably go to some resources to learn on your own how to do that. I have some examples in apps that I'm building for 2 degrees. There is information, at least the minimum that you need, in the Mastering Shiny book, which is the one that I'm using to teach this series. So you should have there everything to get started. But now let's go to our studio and let's do a little demo of how to move from a single file app to an R package. Before we do that, maybe I'll ask CJ to remind me in 10 minutes when it's 20 past for questions and stuff. And also before I do that, is there any comment or question right now before we actually start with the demo? We're good to go? Perfect. Okay, so what you are seeing now on screen is a very simple app. It is in this single file called app.r. And let's just run this file. I'm gonna press Shift-Control-Enter to source this file, and that triggers or that runs the application. So we can see it here in the viewer panel. Basically, what it's doing, it's looking into the different datasets that come with a package called datasets, and that package comes with R. So it has a bunch of datasets, including for example, the very famous dataset empty cars, for example, which should be somewhere here. This one, for example, here, empty cars, and immediately produces a summary of your dataset and shows you a table, right? So that's kind of useful. It's a useful app because sometimes you need a dataset for some kind of example. And you may be wondering, oh, where I could get that kind of data set. So with an app like this one, you can very quickly explore the very large number of data sets that already come with R, and you may not even know that some of the data sets that are there. Like, for example, I really like this very tiny data frame, BOD, this one. I like it because it's very small, and sometimes I just need to show how to do something with a tiny data set. And this is the one that I usually use. So how do we create the package infrastructure, at least the minimum that we need to start benefiting from the things that come with an R package? Okay, for that, I super recommend these guidelines that come with the Mastering Shiny book. There is a section called Converting an Existing App. And we're going to be walking through that very short section to show you basically how minimal it is what you need to do to start using an R package as the infrastructure for your app. So usually in an R package, every code goes in a folder called R. But it is common that if you have a very bare bones app, you wouldn't have that folder already. You could have probably just an RStudio project, and maybe not even that. And you could probably have just one file called app.r. Here we have also a couple of hidden files. Let's see if I can just hide them so that we focus on what really matters. Well, no, we have a git ignore and our history, but those files come with RStudio when you create an app with the RStudio template. Otherwise, you could just have that app.r file. So the very first thing you could probably do is create a folder and call it R. It has to be called that way. That's like a convention in R packages. And then you could move that file app.r. You could move it to that directory. So let's do just that. So we're going to put it in here. And now, once it's there, you could call it whatever, really, that file. And it does make a sense when it's in the root that is called app.r, because that name is kind of special for Shiny, and that name makes it discoverable for frameworks like, for example, shinyapps.io. But now that it's in R, you will also be able to rename it. But before we do that, let's first go to the second step in converting a vanilla single file app into an R package, which is to transform your script into a standalone function. So all you need to do is to take all that code that you have there and wrap it inside a function. So we now need a name for our function. So let's call it, because this creates a dataset summary, let's call it dataset or summary dataset, summary dataset. So let's create our function. We don't need to pass any argument here. We just paste the code that I copied from before. I'm going to tie this up a little bit by indenting the code a little bit. And here is our function. So that's step 2, to transform our app in a function that wraps it. And then to really create a package, all you need, any project that has a file called description with a correct structure, a correct format, or correct content, will become automatically an R package. So you can add such a file with the function use description from the package use this. So let's do just that. So if I am in this project and call use description, then the function will add in the root of the project. In this case, the root of my project is called my app. And now you see how it added this file called description. So that already is on our package. So now my app folder is no longer just a vanilla folder. It's now an R package. So it has all the properties that come with an R package, including the ability to use some keyword shortcuts that RStudio is aware of. But to activate those keyword shortcuts and to start using the R package development workflow, we first need to restart this project. So let me confirm that that is a step that is documented here. Okay, the book is also reminding us that if you haven't already added an RStudio project file in your folder, then it's a good time to do it now. And you could do it with the function use RStudio. You can, do it programmatically. But in this case, I already have a file. I could overwrite it if I wanted with the function use RStudio. And all it's gonna do, in this case, it's gonna detect that I already have a file and it's asking me if I want to overwrite it. Let's say yes. And here we go. I kind of like to run this because when the folder has a description file, the RStudio project file also is aware of the kind of project that it is. It's no longer just a vanilla project, it's an R package project. So I want to overwrite it so that I'm sure that RStudio is aware that this is a package type of project. And then the next thing that we need to do, let's confirm that the book says so, is to restart RStudio. So one way to do that would be to come here to the RStudio icon at the top, and you can click on the name of the same project that you have open, and that will kind of close and reopen and relaunch RStudio in the exact same project. It is not just restarting your R session, which you could do with Shift Control F10, but it is restarting RStudio. So that will, what we'll make is that RStudio now will detect this description file, which wasn't before when the RStudio project had been launched in the first place. And now, having identified this description file, is going to give you a tab, for example, like this one. It's called build, that before wasn't there. Actually, I forgot to kind of mention that, to notice that it wasn't there, and now it is. So that tab is the tab that package developers use, and includes icons like check to run a bunch of checks that confirm or verify if the structure of your package is correct or not, following the policies of CRAN. So that's about it. That also means that you are now ready to use the workflow of an R package development, which means that you can run a command or Control Shift L, and that will load all the functions. And so you no longer need to source any code. You just call load all, and you don't have to type anything because RStudio provides a keyword shortcut. So I'm gonna press Shift Control L, and that will load the code. So if I did any change to my app.r file, it will be kind of now expressed. It will be kind of loaded back into R, so the change will manifest itself. And now I could call, because I have loaded everything in this package, I can also call the function summary dataset. Thanks, DJ. I'm gonna make a pause very quickly. I can call the function summary dataset, and that will call the app, right? And we'll launch it. Right. So now we are kind of, we don't have a perfect package. We have only a minimal package, but as you can see, with that very minimal effort, we already can leverage the power or the benefits of, or many of the benefits of our packages, like including, the workflow that comes with, like just loading the code with Shift Control L, then calling the name of the function that we used to wrap the app and trigger the app. And that also means that you could have in a single project, in a single package, you could have many apps. You are not limited to just one app per project. You can have as many apps as functions you have in your package that wrap Shiny apps. Okay, so that I think it's a good stopping point for some comments or questions, and then we can continue if there is time after this series of questions. So let's go back to your faces here. Do you have any question here? Any comment? Maybe anyone who has used Shiny apps with and without packages? Maybe I'm going to ask a question to Jackson, because you're. Can you tell me, Jackson, if the app that you published on the Guardian or was advertised on the Guardian, is that an R package or is just a vanilla kind of file?
It's an R package. Every Shiny app I make basically is an R package.
Good.
Just because the tools are so useful, I find. Like the testing framework and the checks and the honestly just DevTools load all is like very useful.
Right. Yeah. So I know it might feel like for such a small benefit, like is that all there is? The workflow is pretty fluid. I mean, I have the app there ready to go. I can stop it with escape. I can press Ctrl+1 to jump to the panel to my top left. I can edit the app. Say, let's call what I'm gonna edit now is. Let's pretend that I want the label to be dataset all caps. And now I don't even save the file. I press again Shift-Ctrl-L. That will pop up this window that asks me to confirm if I want to save this file. I'm gonna hit enter. That loads the app. And then because I called the function summary dataset before, it is in the history of calls that I have. So I'm gonna press my up arrow a couple of times, and there it is, the call. So I can now press enter, and I will re-trigger the app. And now the change that I did, which is to make this uppercase, is now manifested here. So if I have any tests, I could also press Shift-Ctrl-T, and I would run all my tests, meaning that any effort that I did, that I invested in making sure that my app works, is now would be automated, and could all that effort would be reused every time I want to check that things go as planned. Any other comment or question here?
I have one other comment, maybe, if people don't see the usefulness of the checks, but if you run like the automated checks that are to check if the package is like up to the standards of CRAN, it helps in your development process to ensure that the application, the Shiny app you're developing, will work on most environments. Like just about, it's not quite as nice as like a Docker file or something like that, but it ensures like reproducibility of the app. So like. And if there's a part of your app that requires you use third-party data or something, it makes it really obvious where those kind of separations are. And I think it really helps with collaborating with other people to ensure that like you don't have some stray scripts that they need to install some random things that are accessing things only on your desktop. It really like packages it all together, forces you to develop like that.
I agree. So let's actually demonstrate in a way what you're saying by making this package a little bit more compliant with kind of CRAN policies. So what the bunch of people that said what a package should look like, wrote a bunch of rules that a project should kind of meet, and those rules are automatically implemented and used to test that your package does or does not comply with those rules through this command that is called rcmd check. So the way to run that command in our studio, the easiest way is to click here this button that is called check, and that will run. For free, you're gonna get all this verification that checks a bunch of things. So you will see that this check will find a bunch of problems now because our package is so minimal. So far we haven't invested any time in making it compliant with the structure of that this bunch of people decided that a package should have. But as this goes on, I'm going to start actually kind of explaining some of those things that make a package compliant, and some of the things that we can change in our app as is now to become basically to pass this check in a clean way. So one of the things that you don't do in our packages and you do in scripts is called library, right? So if you need to use a package inside an R package, so this is my package, it's called my app, and my package needs the package Shiny, right, because it's built on top of it. So I need to use Shiny. So if this is a script, the way I use Shiny is just by calling library Shiny. But actually here you're seeing the check is actually talking about this precise issue right now. So when you want to use a package, what you do is you list that package in a field called imports inside the file description. So you could do that manually, but it's a bit of a pain and error prone. So we don't still have a field called imports, but we can do all of that using the function use underscore package. And we will say which package is the one that we want to use, in this case, Shiny. So this app, the only package that uses is Shiny. So that's the only package that I need. So now you see that the checks have completed, and it detected no errors, but detected 2 warnings and 1 note. So the order is that of severity. So errors are the worst thing that you can have, warnings are the second worst, and then notes are, you need to work on them, but it's not terrible. So it detected a bunch of things, and a bunch are also kind of interrelated. One thing that I have just fixed is that the package Shiny should be declared in imports. Also, I need to. This is kind of a bit of a funky thing in packages. You not only need to list it there, you also need to say that to each function you need to say where it comes from. So I should say something like, okay, the function fluid page comes from Shiny, and then the function select input also comes from Shiny, and so on and so forth. But because that is so tiring, instead what you can do is in a case of a package that you use so heavily, you can just say at import and say the name of the package. This is considered not a good practice, and instead the better practice is to import each function specifically. But in the case of an app where a Shiny app where Shiny is used so heavily, this is one of those exceptions where it kind of makes sense to do it that way. And also, once we have declared the Shiny in imports, and also we have imported it, we can remove that call to library, and that is going to be one of those things that make us pass the checks a bit more cleanly. So I'm going to click here, check again. Still, this is not a perfect package. Sorry, I hit the wrong button. But we should see that the checks are now a bit cleaner, which can support the comment that Jackson just did. The idea that for free you have all these checks, and it helps you detect what issues you still need to address before your package is kind of really ready to share with the world and robust. So as the checks finish, I'm gonna go back to your faces and see if there's any last question or comment, because we are about the time when we need to finish. Okay, in the meantime, I'm gonna say what's the plan for this series. I'm planning to wrap this series in 1 or 2 more meetups because the series was conceived originally as a series about building Shiny apps and also publishing Shiny apps. The one thing that we have absolutely not covered so far is publishing. So the next meetup, I would like to show you I won't cover all the possible ways in which you can publish Shiny apps, but I will cover some very different ways and platforms that will be more or less suitable depending particularly on the audience that you have. For example, is your audience someone who has R in their computer, or is someone who has gonna interact with your app only on the web browser? That kind of question is gonna be the one determining which is the best way to kind of publish your app. So that's gonna be what I would like to be talking next time. And then there is a conditional meetup after that one, which could be a show and tell kind of thing. Maybe Jackson can show us his app. I have some apps to show too. Maybe someone else in the room has other apps to show. So a demo of what we have done, what we have accomplished with Shiny before we actually call it a series and we close the series. So that's the plan, and then I'm gonna be asking you for your ideas about next series. So okay, going back to our studio and just about to finish, I show you that before we had 2 warnings and 1 note. Now we only have 1 warning, and so as you can see, this package is kind of approaching the compliance. And the 1 warning that we have is pretty straightforward. It is telling me that there is no file basically called license, so we need every package needs a license, and it's very easy to fix. I can use something like MIT license, and that will fix the problem. So now I use this, we add that license file, and then when I run check now, my package should be good to go. I'm not gonna wait for this to complete because it's time to wrap up, but instead I'm gonna say thank you and see you next time.
Thanks, Matt.
Before people leave, I'm just wondering if anyone who wants to start talking about some of the changes that Jackson mentioned in the Dev Hangout thread, I'm thinking maybe we can just stay on the call, if that's cool.
That works.
More fun to jump to a completely new Google Meet.
I'm gonna save the